We're going to have more practice finding missing angles in the next two examples. Let's start on the left. Notice there are three missing angles this time: angle M, angle N, and angle P. The only angle given to us was the 125-degree angle, and that's the angle that we're going to use to figure out the measure of the other three. So let's start with angle M. Okay, I'm going to trace angle M in my red color here. Okay, here's where angle M is located. And I'm going to trace the 125-degree angle in green. Here's the 125-degree angle right here. Okay, and if you cover up the ray that they have in common, which is this ray right here, looking at where the red and green is now, this is a straight angle. Okay, which means it's 180 degrees, meaning that these two angles must be supplementary to each other. Okay, so to get the measure of angle M, okay, what we're going to have to do is take 180 degrees because they formed a straight angle and subtract off the 125-degree angle. And so when you do that math, 180 minus 125, that leaves you with 55 degrees. So angle M must be a 55-degree angle. Okay. Let's take a look now at example N, or angle N. I'm going to trace that in purple this time. Let's trace angle N in purple. And again, I'm going to use angle N, and I'm going to use the 125-degree angle. This time I'm looking for green and purple. And if I cover up this ray here, okay, green and purple now I see along this straight angle. So these two angles, angle N and 125 degrees, are also supplementary. So to get the measure of angle N, I'm also going to do 180 minus 125, which is going to give me 55 degrees for angle N as well. Angle N is a 55-degree angle. Now all we have to do is get the measure of angle P, which I'm going to color in orange. Here's angle P. And I'm going to use one of the angles next to it. It doesn't matter if it's angle M or angle N, because if you notice, they're both 55 degrees. So let's use angle N. Okay, that again I have in purple. Angle P I have in orange. So if I cover up this ray, that's purple and orange, I pay attention to where the purple and orange still is. It's along this straight angle right here. So angle P and angle N are supplementary angles. So they add up to 180. So if I take the measure, if I want to get the measure of angle P, I'm going to take 180 and subtract off angle N, which I found out from before was 55 degrees. And that's going to leave me with 125 degrees for angle P. In the picture at the right, this one is different because there are two vertices. All the other pictures only had one vertex, but we have a vertex right here, and we have a vertex right here. Okay, so paying attention to whichever angle we're looking at, we're only going to look at the vertex where it's located. Let's start with angle Y. I'm going to trace angle Y in green. Okay, here's angle Y. And at the same vertex point as angle Y, I see a 157-degree angle, which I'll trace with my red colored pencil. Okay. Now, I'm only looking at the vertex point where these two angles are located, so I'm ignoring this part of the picture. And if I cover up the ray that they share, which is this ray, it's green and red, notice all that's left is going to be the straight angle that I have down here. This is the only thing that's left. So these two angles, angle Y and 157 degrees, are supplementary angles because they form a straight angle. That means they add up to 180 degrees. So to get the measure of angle Y, I'm going to take the 180 degrees and subtract off the 157 degrees. And when I do that, that means that the measure of angle Y is going to be 23 degrees. This is a 23-degree angle. Okay, now I'm going to find the measure of angle X, which is located at this vertex point. So I'm going to ignore the rest of the picture and only look at this vertex point. And I'm going to take angle X and color it with orange. All right, trace it in orange. There's angle X. And at the same vertex point right here, I see a 78-degree angle, which I'm going to trace with purple. Here is the 78-degree angle. Okay? If you covered up the ray that they shared, this ray right here, it's purple and orange, if that wasn't there, all you would have left is this right angle. That means that angle x and 78 degrees are complementary angles because they make a right angle, which means they add up to 90. So to get the measure of angle x, we're going to take 90 degrees and subtract off the 78 degrees, and that'll leave us with the measure of angle x, which comes out to be 12 degrees. This is a 12-degree angle right here. Okay, so if you have more than one vertex point, you have to pay attention to where the angle is located and only look at that vertex point. For angle y, we looked at this vertex point where we saw the 157-degree angle in angle y. And for angle x, we looked at this vertex point where angle x is located and the 78-degree angle is located. In the next example, I'm going to find the number of degrees in each angle, but if you notice this time, they didn't give me the measure of either one of them. I've got a variable in each case, which means I'm going to have to solve this algebraically. And I'm going to do what I've been doing. I'm going to use my colored pencils. I'm going to trace angle A, which is in green here. Here's angle A. And I'm going to trace the other angle, 2a minus 6, with my red colored pencil here. 2a minus 6. Okay, and if you were to get rid of the ray that they share, which is this ray here, if that wasn't there, you would see that they form a right angle, which means that these two angles are complementary angles, and that again means that they add up to 90 degrees. So in order to do this, I'm going to have to set up some sort of an equation and solve it algebraically to get the measure of my angles. So again, they're complementary, they add up to 90, which means if I take this angle A, and I add on this other angle, 2a minus 6, because they're complementary, they have to add up to 90 degrees. So this is the equation that I'm going to solve to figure out the value of each angle. I have a plus 2a, they're similar terms. I can combine those to make 3a minus 6 equals 90. And now this is just a two-step equation, okay? I'm going to isolate the 3a by adding 6 to each side. When you do that on the left-hand side, negative 6 plus 6 is 0, leaving us with only 3a. And on the right, 90 plus 6 is 96, so 3a equals 96. But I don't want the value of 3a, I want the value of just 1a, so I'm going to have to isolate the variable by dividing each side now by 3. 3a divided by 3 leaves us with the 1a that we're looking for. And when we divide 96 by 3 on the right, that ends up giving us 32. So the value of a equals 32. And if I look at my picture again, this angle was a, so I know that this is a 32-degree angle. To get the measure of 2a minus 6, I'm just going to take the value of a and substitute it into the expression. 2 times 32 minus 6. And now follow your order of operations. We'll multiply first. 2 times 32 is 64. And when you subtract 6 from 64, that leaves you with 58. So this angle is a 58-degree angle. In our last example, again, we're going to find the number of degrees in each angle, and I'm going to have to take an algebraic approach again because I don't know the measure of either angle. They both have a variable in it. So I've got my angle here on the left, which is 2x plus 19. I'll trace that with green. Okay, and then I've got my other angle, 3x plus 4, which I'll trace with red. There's the other angle, 3x plus 4. And if you were to get rid of the ray that they share, this ray right here, well then you're going to be left with that straight angle, which means that these are supplementary angles, and they have a sum of 180 degrees. So what we're going to have to do again is set up an equation so that we can figure out the measure of each angle. So I'm going to take this angle, 2x minus 19, 2x minus 19, and I'm going to add it to the other angle, which was 3x plus 4. And I said they're supplementary angles, which means when I add these two angles together, they make a straight angle of 180 degrees. So there's our equation, 2x minus 19 plus 3x plus 4 equals 180. I'm going to rearrange this so that my similar terms are together. I'm going to have 2x plus 3x, and then I'm going to have negative 19 plus 4 equals 180. And now I'll make my two-step equation. 2x plus 3x makes 5x. Negative 19 plus 4 is equal to negative 15. And again, our sum is 180 degrees. There's your two-step equation. Let's isolate the variable term by adding 15 to each side. Okay, when we do that on the left, negative 15 plus 15 is 0, leaving us with 5x. On the right, 180 plus 15 is equal to 195. 5x equals 195, but again, I only want the value of 1x, so I'll isolate the variable by dividing each side by 5. 5x divided by 5 leaves us with just 1x. And if you do 195 divided by 5 on the right, that leaves you with 39. So I know that x equals 39. But this time, well, neither one of these is just x. So I'm going to have to substitute the value of x into each of these expressions to figure out the measure of the angles. Let's start with this angle, 2x minus 19. When I substitute, that becomes 2 times 39 minus 19. Order of operations, I'll multiply first. 2 times 39 is 78. And then when I subtract 78 and 19, that leaves me with 59 degrees. So this angle here is a 59 degree angle. Okay, I'll do the same thing over here on the other side. I've got 3x plus 4, which becomes 3 times 39 plus 4. Again, multiply first, 3 times 39, that's going to give you 117. And then when you add 4 with 117, you get 121 degrees, making this angle right here 121 degrees. So again, make sure you look at your picture, determine what kind of angle relationship you're working with. Are they complementary angles that add up to 90 degrees because they make a right angle? Or are they supplementary angles that add up to 180 degrees because they form a straight angle? Look carefully at your pictures. Feel free to use colored pencils to help.